All right, picture this. You're completely in the zone, relying on an AI coding assistant to scaffold out a new feature, only to realize it just hallucinated a whole bunch of outdated syntax. It's incredibly frustrating, right? The AI model is brilliant, sure, but it's basically trapped in the past by its training data cutoff. Well, today, in this explainer, we're going to fix exactly that. We're rolling up our sleeves for an architectural whiteboarding session to solve this problem once and for all. We're going to transform the Gemini CLI from just a simple local file analyzer into a fully connected, proactive agent that actually reaches out to the real world. So here is our whiteboard roadmap for today. We're covering the agentic coding workflow, building the bridge with MCP, live docs with Context 7, a security-first approach, and finally, the power of extensions. Let's get right into it. Section 1. The agentic coding workflow. Let's establish the foundational baseline of the Gemini CLI in our local environment. There's a pretty stark contrast in modern development right now. You've probably heard the term vibe coding. This is where you basically just loosely throw prompts at an AI, endlessly copy and paste errors back into the chat, and just kind of fumble around until something works. Honestly, it usually produces what we call AI slop, messy, buggy code. This explainer is definitely not about vibe coding. Instead, we're focusing entirely on agentic coding. This is a nuanced, targeted approach where you, the developer, are firmly in control of the loop. You're working on smaller features one at a time, actually reviewing the generated code and dipping into the weeds yourself. It's structured, it's professional, and it yields infinitely better results. And to really support that professional workflow, the Gemini CLI brings something absolutely massive to the table. 1 million. Seriously, wrap your head around that number for a second. That is the token context window available on Gemini's generous free plan. Now, if you aren't super familiar with tokens, just think of them as the AI's short-term memory. A 1 million token limit means this model can hold a staggering amount of your project's history, your entire conversation context, and your whole code base right in its head, all at the exact same time. This huge capacity is the literal engine that makes all our next steps possible. Section 2, building the bridge with MCP. We've got our powerful local agent, but right now it's totally isolated. It's time to draw the bridge. So the crucial point is understanding how this connection actually happens. By default, coding agents can't just browse the open internet to talk to a back-end service like Firebase, right? To solve this, we use the Model Context Protocol, or MCP. Interestingly enough, this is a standardized protocol originally created by Anthropic, but it is beautifully supported right out of the box by the Gemini CLI. Think of MCP as the fundamental bridge architecture. It extends the AI's capabilities, allowing it to trigger very specific targeted external tools. Let's think about the actual data flow of this architecture. The AI model itself isn't reaching out to these external services. It doesn't actually know how to interact with them directly. Instead, when you add an MCP server, that server exposes a set of functions, or tools, to the Gemini CLI. The AI simply says, hey, I need you to run this specific tool to get some data. And the MCP server executes the code, sends the request, and hands the response right back to the AI as context. Section 3, Live Docs with Context 7. We are bringing our bridge to a very specific destination. Let's look at why this particular destination is an absolute game changer. Context 7 is essentially a massive collection of the most recent official documentation for frameworks like Next.js, React, Vue, and Tailwind. By hooking up the Context 7 MCP server to our Gemini CLI, we give our AI the ability to dynamically search and read these live docs. Remember that hallucination problem we talked about at the very beginning? Yeah, this is the cure. If we're implementing a new feature, we can just tell Gemini to check Context 7 first. This completely prevents the model from relying on outdated training data, ensuring your generated syntax is modern and spot on every single time. Section 4, a security-first approach. Before we just start firing off external requests, we absolutely must secure the toll booth on our bridge. Okay, let's break down this security-first workflow. When you set up an MCP server like Context 7, it's going to require an API key. Now, the absolute worst thing you can do is hard code that sensitive key directly into your project's settings.json file. Why? Because it might accidentally get pushed to a public GitHub repository, and then you've got a real problem on your hands. Instead, we use a 3-step professional approach. First, generate your key. Second, save it in a local hidden .env file. Third, inside your settings.json, you dynamically reference that variable using a $sign and curly braces. The Gemini CLI is actually smart enough to pull the key straight from your environment variables, keeping your project completely secure. Once that secure connection is locked in, honestly, the developer experience is practically magic. You don't have to explicitly type out complex commands to trigger the MCP server. If you simply prompt Gemini with something like, use context 7 to check if I've set up Vitesse correctly, the AI automatically discovers the available tools. It recognizes the intent from your context and then proactively pauses to ask your permission, saying, allow execution of MCP tool get library docs. You just hit yes, and it seamlessly does the heavy lifting for you. It's incredibly smooth. Section 5. The power of extensions. Finally, we're going to upgrade our standard bridge into a massive superhighway. To really understand the leap we're taking here, we kind of have to compare these two approaches side by side. Up until now, we've talked about manual MCP setup, right? That requires editing JSON files, managing .env variables, and it's usually specific to just a single project. Plus, it only gives you the server itself. Gemini CLI extensions, on the other hand, are a total paradigm shift. They're installed globally with a single terminal command. But more importantly, they are bundles. They don't just give you an MCP server, they package the server alongside custom commands and customized prompts. Let's make this super concrete with the Firebase extension as our prime example. When you install this extension, you aren't just getting the ability to list out your Firebase projects. You're getting an entire tailored workflow. It bundles the Firebase MCP server, sure, but it also includes Markdown prompt libraries. These are essentially internal memories and context files that tell the AI exactly how Firebase works. Plus, it injects custom / commands directly into your CLI. So you can type /Firebase init to start a database or /Firebase deploy to push your code. It's an absolute all-in-one powerhouse. And this brings us to the absolute core takeaway of today's whiteboard session. By utilizing MCP and extensions together, we're fundamentally changing the nature of this tool. Extensions transform the AI from a local file analyzer into a fully connected, proactive agent capable of managing cloud services directly. You're no longer just asking it to format your CSS, you're empowering it to read the latest framework documentation and literally deploy infrastructure to your cloud backend. It's wild. So that barrier between your local code and the outside world, it is officially gone. You've got the massive 1 million token context window. You have the secure bridge via MCP. You have the real-time knowledge of live documentation. And you have these super-powered bundles of Gemini extensions. Now that your AI has the secure keys to external APIs and live documentation, what will you build next? Seriously, take this architecture, apply it to your own code base, and experience true agentic coding for yourself. Catch you next time.